Hey everybody! We're going to be looking at lesson 3.4a today, solving multi-step inequalities. First thing I want to look at with you is the difference between an equation and an inequality. So we're going to solve both an equation and an inequality, and we're going to think about what's similar between the two and what's different between the two. Notice that these numbers I'm using are the same. The only difference here is that I have an equal sign in the equation and a greater than symbol in the inequality. So what I'd like you to do on your notes sheet is just go ahead and start solving this equation like you normally would. I'll do the same thing as you're doing it. So hopefully we came up with the same answer. Now notice with an equation, we only get one solution in this particular equation. Now let's take a look at the inequality. I'd like you to solve it, and I will solve it here together at the same time. Now I'm going to kind of show you a little trick. I told you the other day that when we get to multi-step inequalities, I would share a trick with you for how to remember the flip rule. So if I start solving the inequality like I normally would solve like an equation, I'd first have to add 6 to both sides like I normally would. Now, if you think about the party scenario, here I'm sending home my acquaintances, and they really don't care. So they're just going to go home. Now, if I bring down the negative 3t, notice this negative 3, this would be considered the closest friends. Now notice here that they have a negative attitude. And when I go to send home my closest friends by dividing both sides by negative 3, because they have a bad attitude, they are going to totally flip out. How cool is that? See, I know you're totally impressed, aren't you? Haha, so there we go, we flip. So notice with an inequality, we're getting all numbers that are less than negative 7 as solutions. So here we get one solution, and here we get infinitely many solutions. Everything less than or to the left of negative 7 on the number line. So when we think about similarities and differences between the two, the steps in which we solve them are the same. See, I'm adding 6 to both sides, and then I'm dividing by 3 to both sides. Some differences would be in the number of solutions I get, and the fact that here with an inequality, I sometimes have to do the flip. I can also check both of my solutions, and we talked about that as well. So I guess that would be similar between the two as well. All right, let's take a look at some examples of solving multi-step inequalities. All right, number 1. On your notes sheet, if you want to just fill in the 45 here. Here we can see we've got a multi-step inequality. I see distributive property, and there's going to be some combining like terms. If you want to pause the video and try it on your own, you can do that. Otherwise, we can do it together. So I'll distribute. You can distribute too. Negative 15 times negative 3. And then I'm going to bring down all of the plus 3j. So I've distributed. Now I'm going to combine like terms. Negative 15 plus 3. All right, so I've simplified this entire side. And we're just going to bring everything down. Okay, so the goal here is to get the j by itself. So you know what to do, right? Send home those acquaintances. Subtracting 45 to both sides. So nothing's flipping. Here it looks like I'm going to get 0. But now, when I go to send home the closest friends, notice they have a bad attitude. And when I send them home, they are going to totally flip out. Perfect. See, we flip it. 0 divided by 12 or 0 divided by negative 12, here's just 0. Anytime you take 0 divided by any number, you get 0. So I've got j all by itself. Now if I'm going to go to graph this, I'm going to want to reverse the inequality and get the variable on the left-hand side. So big mouth is opening toward the 0. There's the big mouth opening toward the 0. And I have all numbers that are less than or equal to 0 as my solutions. So we will graph that. I'll just make this a 0. Looks like a closed circle. And everything to the left gets shaded. So there we have our multi-step inequality with distributive property, combining like terms. We had the flip rule, and we had to reverse it as well until we got a chance to graph the solutions. Lots of steps in that one. All right, here on number 2, I believe that on your note sheet, this left-hand side is blank if you want to fill that in so you can get the entire inequality before we start to solve it. Now what's different about this one is I noticed we have a T on both sides of the inequality symbol. Might be easier to see that if you draw that line down the middle. So it looks like the left side is simplified. You have the right side to simplify. So go ahead and distribute, combine like terms. I'll do it, you do it, we'll do it together. I'm getting 2t minus 5t. And then I'm ready to bring down my inequality symbol. We'll see what we have on both sides here. So after I've distributed and combined like terms, I now need to move the variable to one side or the other. I have a t on both sides here. Between a -3 and a 4 is obviously bigger, so we want to bring all the t's to the bigger side. So to undo this one, we'll add 3t. So that's going to give us 5 plus 7t is greater than, of course, -2 on this side. Okay, now that we have the t on one side, our goal is to isolate it and get it by itself. So, of course, we're going to keep the 7, send home 5, subtract. I get -7 over here. Now I'm going to go and send my closest friends home. Notice they do not have a negative attitude, right? I don't have a bad attitude. I'm just going to divide by 7. Nothing's flipping out. T is greater than, and then here when I divide I get -1. So here is the set of solutions that make the inequality true for t. So open circle at -1. Looks like everything to the right gets shaded. So these are all the solutions that would work for the letter t in this inequality. Perfect. So we've seen an inequality with multiple steps. We've seen an inequality with variables on both sides. And now we are ready to take a look at some special types of inequalities. So if you want to flip your notes over, you will see that we are going to be looking at something that we're already familiar with on the left and comparing it with something that is new on the right. So on the left here, there's an equation which you should be completely familiar with solving. So I want you to go ahead and solve it like you normally would in a regular equation. Go ahead. I'll do it, you do it. Already with the first step, I see that I have an identity. 14 minus 6n is equal to 14 minus 6n. And right now at this point, you can probably tell me that there's infinitely many solutions for n. I'm going to take it one step further. I see I have an n on both sides, and so I want to move the n's to one side. In order to do that, I would have to add 6n to both sides, getting the n completely to cancel out, meaning I can't solve it for n anymore. If I bring down what I have left here, I still have an identity, identical on both sides. Also, I have a true statement. And we know that when I have a true statement here like this, or an identity, we know that this is infinitely many solutions. So n could be pretty much anything, any real number n could be. So now that's something that's familiar to you. So let's take a look at the right-hand side here at an inequality. This is something that's new, but I want to compare it to something that you already know. So all the numbers are the same. The only difference here is that we have an equal sign and an inequality symbol. So go ahead and let's start to solve this inequality. Let's switch colors here. So you would distribute like we did before. All right, now you're noticing here that we have the same thing on both sides. 14 minus 6n and 14 minus 6n. If you notice here that these two negative 6n's are identical, you might see, okay, we have a special situation, just like we did with the equation. Is it true that 14 minus 6n is less than or equal to 14 minus 6n? Yes, it's true. Now, this is going to tell you that there's infinitely many solutions, or all real numbers would be a solution. However, it's a little bit harder to see this with an inequality, so I would suggest going another step with this. Let's move the variable to one side. So when I do that, n cancels out, and I end up with 14 is less than or equal to 14. Is that true? Yes. Because this is true, that means that any number would be a solution for n. And instead of infinite solutions like we say with equations, we're going to say that all real numbers are solutions to this inequality. Because think about it, with an inequality, no matter what inequality you're solving, you're going to have infinitely many solutions. So we have to say that all real numbers are going to be solutions, not just the left side of a number line or the right side, but both sides. Okay? So down at the bottom here, now you will see, I have this statement on the bottom of my sheet, but you have it on the left of yours. So I'm going to write, if a true statement occurs, the solution is all real numbers. Okay, so if the variable completely cancels out and I have a true statement, answers all real numbers. Okay, so I bet you can probably guess what's going to happen next in number 4. Here we go. I did the same thing. I'm comparing an equation, which is something you're familiar with, to an inequality, which is something that's new. All the numbers are the same. The only difference is the symbol right here. So let's go ahead and start solving the equation like you normally would, and you'll recognize what's going to happen right away. Looks like I just have the right-hand side here to simplify. And you're recognizing this probably right away. You see, okay, I have 4p on both sides. I know this is a special case. It's not an identity, and so I know it's no solution. However, I'm going to take it another step. I want the p on one side, so to do that, I'd have to subtract it. It cancels out, which means I can't solve for p, and I end up with 3 equals 6. And you guys know that that's not true, so therefore, there's no solution, right? Remember that? Okay, so I end up with a not true statement, variable canceled out. Let's see what happens with the inequality. So start solving it again, combine like terms. I'm going to get 4p plus 6. Inequality symbol this time, you guys. Okay, so now I see again 4p. This is a special case, but we need to go a little further here. I'd suggest going one step further with the inequalities. It really is helpful. So minus the 4p and cancels out. We get 3 is greater than 6. But is 3 really greater than 6? No, that's not true. So because I'm left with a not true statement, this means there are no solutions to this inequality. There's no value of p that would ever make this true. Okay? So on the left side of your notes, you're going to see this statement. If a not true statement occurs, there is no solution. Okay? Just like with equations. So take it a step further, because you're either going to get a not true statement, which means no solution, or you're going to get a true statement that means all real numbers. And sometimes kids will go ARN for all real numbers, and obviously I know what that means. Okay, so that's number 4. All right, last one here.